In this problem, one of the things we have to do is find the equation for any horizontal asymptotes given a rational function. To do this, there's shortcut rules. There's actually three cases. If you let me abbreviate the degree of the polynomial in the numerator as dpn and the degree of the polynomial in the denominator as dpd, it shortens the list down a little bit. So I'm going to go through the three cases, and here's the first case where the polynomial in the numerator is linear, so its degree is equal to 1. The polynomial in the denominator is a quadratic, so its highest degree term is 2. So we have the degree on the numerator is a 1, the degree in the denominator is a 2. So here's a case where the numerator is less than the denominator, so the answer will be the horizontal asymptote y equals 0, and this is exactly what you type in to MathAS. So by the way, given the graph here, what that means is for very large x values, your y values, if you look at the outputs, are getting really, really close to 0 right here, not only in the positive direction, but also for large x in the negative directions as well. As x gets very large negative, your y values of these points are getting closer and closer to 0. The second case that I'd like to explore is the reverse of this, where I stick the quadratic in the numerator and a linear polynomial in the denominator. So here we have that the numerator is degree 2, and the denominator, this is degree 1, highest exponential 1 here. So in this case, the degree of the polynomial in the numerator is bigger than the 1 in the denominator, in which case they will not be a horizontal asymptote. If you look at this picture, it looks like it has an asymptote. We actually call this a slant asymptote. But the question is to find the equation for the horizontal asymptote, and there simply isn't one. As x gets very, very large in the x direction, the graph does not resemble a horizontal line at all. It looks like a slanted line. So in MathAS, you would write this as DNE because it does not exist. The third case that you'll explore is if the degrees are the same. So in this example, I made a quadratic divided by a quadratic. So the numerator is degree 2, the degree of the polynomial in the denominator is degree 2, and 2 is not less than 2, 2 is not greater than 2, but they are equal. In this case, what you do is you look at the leading coefficients, and the leading coefficients here are 20 and 4. If you remember right, the word coefficient means the number in front of the variable. In fact, here the coefficient's -1, here the coefficient's -2, but we want the leading coefficient. The definition of a leading coefficient is the number in front of the variable with the highest exponent. So this is a quadratic, the highest exponent's a 2, its coefficient is 20. In the denominator, the highest exponent's a 2, and its coefficient is a 4. So the answer to this would be to form the ratio, which means to divide, the two leading coefficients. So the answer would be that the graph approaches the horizontal line. You can actually see it right here in the graph, that it looks like the graph levels off around y equals 5. And this is evidenced by the fact that when you take 20 divided by 4, that simplifies down to be 5. So in MathAS, you would respond that the answer is y equals 5. So going back to the MathAS question, let's look at the ones that were asked in there. In this example here, the numerator is a constant, and by definition, constants are degree 0. My denominator is linear, so that's a 1. So that would be degree 1. So in this case, because 0 is less than 1, my numerator is less than my denominator, and you get y equals 0 out of that. So this one would be y equals 0. Let me write that down. And in my second case, I have that the degree of the numerator is 1, the degree of the denominator is 1, therefore they're equal, in which case you look at the leading coefficients again. Sometimes I refer to this for my students as the thumb rule. If you were wondering what that is about, I'll show you what that is in a second. So basically what you do is you take the leading coefficient in the numerator, that's a 10, that's the number in front of the variable with the highest exponent, which was right here. Down here the highest exponent was a 1, its coefficient's a 5. So the horizontal asymptote would be g of x equals 10 over 5, namely 2. And I think MathAS reverts back to the generic y equals instead of the output variable g of x. So here the answer would be y equals 2. If you're wondering why I call that the thumb rule, it's because on the test, I tell my students that if you know that the problem is such that the degrees are equal and they're in descending order, that puts the leading coefficients over here on the left, meaning that the answer was sitting here all along. So if you knew that, you'd actually be able to take your thumb and on the test cover up all of this stuff here. And if you took your thumb and did that, it's kind of silly, but my students remember it. They know what the thumb rule means, and if you did that, you'd get the answer y equals 2 out of that. But if you're going to use that to help you remember, just remember that that only works if it's in descending order. So for example, I've had students that when confronted with the same exact equation, all I'm doing is copying this equation down and reversing the order of these two terms, putting the 8 first and the 10x second. So here I guess you'd have to say that you'd have to apply the crooked thumb rule or something, but so the better way to explain it is it's the ratio of leading coefficients, because this is still the variable with the highest exponents. The leading coefficient is still a 10 regardless of where you put it. Down here the leading coefficient's a 5, so you would still get that ratio to be 10 over 5, namely 2. The other way of doing it is I just tell my students, if you're given a polynomial that's not in descending order, write it in descending order this way, and then you can apply the thumb rule. Moving on to the next one. Here we have a case where you have a quadratic on top. A quadratic is a polynomial of degree 2. I know that because the highest exponent here is a 2. The highest exponent in the denominator, because it's linear, the highest exponent I see is this right here is a 1. So we have the degree of the polynomial in the numerator is a 2, and the denominator is highest degree is a 1, and since 2 is bigger than 1, it falls under this rule. So there's no horizontal asymptote, therefore the answer is that it does not exist. Last but not least, we have another thumb rule. Top is degree 1, so linear. You could think of this as y equals mx plus b, where the b is just 0, if you will, so it's just not written. So this is degree 1, highest exponent of 1. In the denominator we have a highest exponent of 1. Therefore the degree of the numerator is equal to the degree of the denominator. And again, you look at leading coefficients. The fact that the coefficient isn't written here means that it's a 1. So if you did the ratio there, you'd get h of x equals, or for purposes of Math AS, I guess we're using y equals, and that horizontal asymptote would be negative 1/9. It doesn't matter where you put the negative. So h of x equals negative 1/9, or you could write that as y equals negative 1/9. And again, if you do like that thumb rule, because these are in descending order, you would put your thumb over everything except for that, and you'd see that the answer is negative 1/9.